To the third part of the lectures, we talk about the structures and functional views. The computer is a very complicated hardware and very complicated software. So normally when we study a complicated system, we usually start with the block diagrams. In the block diagrams, we describe only the main functional modules of the machines of the system. And we do the same way for the computer systems. To have an overview look at the computers, we normally talk about the structural views and the functional views. The structural view is the way in which the components are interrelated. And the functional views give you an idea of how the operations of each individual components when they work together. So in terms of structures, we can take a look at the computers from the top level. It will consist of the functional modules. The first one is the CPU. That is the brain of the computers. And to enable this brain work, we need the main memory. The main memory is where the programs and the data is stored. And during the operations of the computers, program will be put on the main memories and the CPU will read instructions by instructions and execute it. The third module is the I/O system. This is where your computers will negotiate interface with devices like the monitors, the keyboard, or the printers, or the microphones, for example. And these functional modules will connect together through a system bus. These are the main components of computers. When you have a carefully look at the CPU, you can see that the CPU will consist of the following internal modules. The first module is the ALUs. ALU stands for Arithmetics Logic Units. That is the units that carry out all the computational executions inside the CPU. These calculations involve the arithmetics operations like addition, subtractions, multiplications, or divisions. And the logical operations like the AND, OR, NOT, or exclusive OR. The second modules inside the CPUs is the groups of registers. So what is the register? The registers are actually the internal memories of the CPU. We will talk about them later. And the third modules, or the heart of the CPU, is the control unit. It will carry out all the operations inside the CPU. And this functional unit will control all the input, output, encoding, decoding instructions when the CPU is working. And if you have a look deep inside the control units, you can see that the control units will consist of the sequencing logics and the control memory modules. And these two modules will execute through the control units, registers, and decoders unit. I can say that this is a very illustrative figure, and I intend to use colorful items so that you can easier to remember the structural views of computers. This is a text to describe individual modules in the last slide. In functional views, instruction set of the CPU is very complicated, and we have hundreds of instructions. But these instructions may be categorized into four main functions. That is the data processing group, the data storage groups, data movement group, and the control instructions. And all these instructions will work together to make the whole computer work. We move to the next part of this chapters. We talk about computer abstractions. Abstractions is the way that we describe the details of a system and we focus on main functions of it solely. If we look at the computers in an abstract way, you can see that the computers will consist of two main parts. That is the hardware, or we can say the physical device, and the software, that is the applications run. The physical device, if you take a look at it carefully, it will consist of the digital circuits, the CPUs, or we normally call the processor, the chipset, the motherboard, hard disk drive, floppy disk drive, many interface, or many other mechanical items inside the case. These are the computer hardware, right? And for the computer software, we have many kinds of instructions run on it. So the gap between the user applications and the hardware is big. So the functional modules, if any, between these layers, that means the computers, like hardware layers and the computer software layers, is very complicated because it must undertake so many functions. To make it easier for studying the models, usually many functional layers are introduced in between the applications and the hardware layers. And it depends on the studying aspect or designing aspect. The layers might be called the layers that introduce between the hardware layers and the software layer may be named differently. For example, in terms of architectural aspect, that means for developer views, the layers introduced between the software and the hardware can be seen on the drawing here. From the bottom up to the top, you can see the computer hardware is built on the digital circuit, and above the digital circuit we have the microarchitectures. Then comes the instruction set architectures of the CPU, right? And next is the operating system, which is start the software layers. Next, the assembly language, and lastly, we have the problem-oriented language layers. I want to repeat that these layers are names depends on the views of the user or the designer. In this layer, in these pictures, we say in terms of the developers. We have this layer in terms of developers. And the implementations between the layers will be between the problem-oriented language and the assembly language. We use the compiler. The compiler will compile high programming language into the code that can represent in low-level language, that is assembly language. Right? And between the assembly language and the operating system is the assembler. Assembler is actually the compiler that compile assembly code into the code that can be executed by the operating system. Between the operating systems and the instruction set architectures, we have partial interpretations. And between the instruction sets and the microarchitectures, we have the microprograms. And between the microarchitectures and the digital circuit, we have the hardware of the computers. Through layer implementations, designers or the students can deeply investigate the particular quants depends on the aspect that they want to have a look at it. Okay, so for you are developers, you will be developers, so you will study these layers. That's mean the top higher layers from instruction set architectures, the operating system, the assembly language, and high level language. And in this course, we'll focus on assembly language and the instruction set architectures. And you also have another course about operating system. About the problem-oriented language, you learn a lot. For example, C, C++, Java, or Python. These are problems-oriented language. For the computer engineering students, they will study the lower two layers, that is the microarchitecture layers and the hardware or the digital circuit. And we finished our first chapters. These chapters give you overviews about the computer's architectures. Thank you for joining me.